Hello everyone, welcome to my another lecture on Cauchy's integral formula. This is the third lecture on Cauchy's integral formula. Earlier I have explained very nicely Cauchy's integral formula, and there are three sums are there, that is lecture 1, lecture 2. In lecture 1, lecture 2 I had explained very nicely Cauchy's integral formula along with examples. In this lecture, the learner will be able to understand two sums, that is question number 4 and 5. Calculate the integral using Cauchy's integral formula, this, where C is the center, that is mod z equal to 3 by 2. And this sum, that is cos z by z square minus 1 around the rectangle with vertices this. Okay, 2 plus minus I minus 2 plus minus I. In these two sums I will do. Okay, these two sums I have taken from university question paper. Very important sum. That is for B.Sc, B.Tech, M.sc, IIT-JAM, CSIR-NET, GATE exam. So here you will see earlier, that is example 1, 2, 3. In these three sums, we had seen that all singular point lies inside the circle. And in this sum, that is example 4, this is quite different. Like all singular points will not lie inside the circle. Some of them are outside the circle. Okay, that is mod z equal to 3 by 2. This is the difference. This is very important sum. So to see the sum, that is, firstly, what will you do? You have to find the singular point of this function. What is the singular point? To get the singular point, I'm solving now example 4. Example 4. Solution. That is solution example 4. Okay. Solution example 4. So to get singular point, we put denominator equal to 0. That is z into z minus 1 into z minus 2 is equal to 0. Therefore, z equal to 0, 1, 2 are the singular points. What are singular points? That is, singular point is a point that, for that point, the function is not defined. For what point of z, this function is not defined. That is when z equal to 0, z equal to 1 or z equal to 2, if we put over this function, then fz is not defined. So this is the singular point. So we can say z0 equal to 0, z0 equal to 1 and z0 equal to 2. So this, as you can define z0 equal to 0. 0 means we can write 0 plus 0 into I, that is 0, 0. Okay. Z0 equal to, these are the singular point. Z0 equal to 1, that is 1 plus 0 into I, that is 1 comma 0. And Z0 equal to 2, that is 2, this equal to 2 plus 0 into I, that is 2 into 2 comma 0. Okay. As you know, x plus iy equal to x comma y. So these are the points. These are the points of singularity. Now, after getting the singularity, what will you do? So you have to draw the closed curve, which will be given. This will be always given. Mod z equal to 3 by 2. See, mod z is equal to 3 by 2. So mod z can be again written as, that is x plus iy mod equal to 3 by 2. That is x square plus y square equal to 3 by 2. This is under root. That is x square plus y square equal to 3 by 2 whole square. So this represents a circle whose center is 0, 0. Why center 0, 0? Because x minus 0 whole square plus y minus 0 whole square is equal to 3 by 2 whole square. That is x minus h whole square plus y minus k whole square is equal to r square. That is center is hk, radius is r. So here center is 0, 0, radius is 3 by 2. Radius is 3 by 2. So I'm just drawing a circle whose center, drawing a circle like this is a circle whose center is 0, 0 and radius is, this is x coordinate, x, this is y. This is real axis and this is known as, y axis is known as imaginary axis. Okay, real axis and imaginary axis. Now what is this point? Because radius is 3 by 2, so this point is 3 by 2 comma 0. 3 by 2 comma 0 radius. So this length is 3 by 2. Okay, this length is 3 by 2. This length. Okay, so now you see, after getting the that is, this is a closed curve. This is a contour C. Contour C is the contour closed curve C. So after getting this that is closed curve, you have to check. You have to check whether this 3 point lies inside the circle or not, or outside the circle. So 0, 0. This is 0, 0. This is at this point it is 0, 0. 0, 0. So this is inside the circle. Then it is 1, 0. 1, 0 will be here. So this is 1 point. This is suppose this is 1 comma 0. 1 comma 0. And 2, 0. You see 2, 0. This is 3 by 2 means 1.5. So 2, 0 is outside the circle. This point is 2 comma 0. So this is outside the circle. These two are inside the circle. Inside C, and this is outside C, outside C, outside of C, inside of C, this is outside of C. So this point is outside of closed curve and these 2 points are inside the closed curve. So we have to take these 2 points. Okay. So now what is actually fz? So this is the point, that is z minus z equal to 2. So this is the point which is outside the circle. So what will be fz? Follow me. Fz will be here. Fz will be, that is 4 minus 3z. 4 minus 3. Follow me. 4 minus 3z by 4 minus 3z. Sorry. Fz will be 4 minus 3z by z minus 2. Z minus 2 by z into z minus 1, we can write. Z into z minus 1. This is the integration actually. That is integration of this thing. So this integration can be written as this. Why I am taking that is z minus 2 in the numerator, that is of this? Why? Because this is the outside of C. Outside of C. So I have taken this is the C. So here fz equal to, I am taking here now 4 minus 3z by z minus 4 minus 3z by z minus 2. This is your fz. This is your fz. Suppose all these 3 points inside the circle, then what will be the fz? Fz will be only 4 minus 3z. Only 4 minus 3z is fz. Because all these 3 points inside the circle, if it contains all these 3 points, that is all this singularity, that is singular, these are the singular point I told, all singular point inside the circle, then fz will be 4 minus 3z. Here z equal to 2, that is 2 comma 0 is not inside the circle. So we are taking, that is dividing numerator and denominator of this by z minus 2. Then z minus 2 from denominator it will cancel. Then z minus 2, 4 minus 3z by z minus 2. So this is your fz. This is your fz. Now we have to apply, Cauchy's integral formula. Cauchy's integral formula. Cauchy's integral formula. After getting, follow me once again, I repeat, for this sum, firstly you have to do, what will you do? Firstly you have to find the singular point, and then you have to find the, that is closed curve. Closed curve is given. After getting the closed curve and singular point, you have to check whether the singular point inside the circle. If all the singular point inside the circle, then we have to take the numerator part is fz. If all the that is singular point are not inside the circle, suppose here you see z, the 20 is not inside the circle, so I am dividing numerator and denominator of this part by z minus 2, then we are getting this part is equal to z. Now what is actually Cauchy's integral formula? I already explained very nicely. So before this, I request all of you, you have to see my lecture number 1 and lecture number 2 of Cauchy's integral formula. Just I am writing it here, that is what is actually Cauchy's integral formula. Cauchy's integral formula. So if fz is an analytic function within and on a closed curve C, and z0 is a point within C, then f of z0, is equal to 1 by 2 pi I, just follow it, integral C fz by z minus z0. This is dz. This is the, Cauchy's integral formula. This is Cauchy's integral formula. From this we can write the cross multiplication. This into this equal to integration of this. Therefore, integration C fz by z minus z0 is dz is equal to 2 pi I into fz0. fz0. So this is it. Now we have to apply this. Okay, for these 2 points, the points which are inside the circle. Okay, okay. Now we can write, that is this actually, therefore using, I am removing this part, using fz equal to this, and that is this again can be written as, that is therefore this equal to, this integration is equal to, we can write integration fz by actually z into z minus 1 dz, this equal to, because this I have taken fz. Okay, so this equal to fz, that is integration c along c, that is c, this is fz by 1 by z into z minus 1, break into partial fraction, that is 1 by z minus 1 minus 1 by z. This is by partial fraction, as we know how to break this into partial fraction. So now this again, by this is partial fraction. This again can be written as, just I am removing this part. Therefore, this can be written as, that is integral, that is c 4 minus 3z by z into z minus 1 into z minus 2 is equal to, that is fz by this actually, is equal to c fz by z into z minus 1 dz, this equal to that is equal to c fz by z minus 1 dz minus integration c, thus break into 2 parts. that is fz by z dz. Okay, fz by z dz. Therefore, by Cauchy's integral formula. Therefore, by Cauchy's integral formula. Therefore, by Cauchy's integral formula. By Cauchy's integral formula. Cauchy's integral formula. By Cauchy's integral formula. This again equal to, you see, this equal to f of z0, 2 pi I. That is, here you have to write 2 pi I. So this integration is this integration is equal to, what is the formula? 2 pi I. What is the formula? 2 pi I into f of z0 equal to 1 minus 2 pi I into f of z0 equal to 0. Where fz equal to, here fz equal to 4 minus 3z, 4 minus 3z by z minus 2, So now you have to calculate f of z0 equal to 1, when z0, that is, this is what is, that is z equal to 1, that is when z equal to 1, then f of 1 is equal to 1 means actually z0 value. Okay, if z0, f of z0 equal to 1, if we put z equal to 1, then 4 minus 3 by, that is equal to 4 minus 3 into 1 by 1 minus 2, 1 minus, that is minus 1 we are getting. And when f of z0 equal to 0, when z0, that is equal to 4 by, this part will be 0, 4 by I minus 2, 4 by minus 2, that comes minus 2. Just I am putting the value over here, that is 2 pi I into minus 1 minus 2 pi I into minus 2. So minus plus 4 pi I minus 3. So this will be minus 2 pi I plus 4 pi I, that is equal to 3. 4 pi, that is, here is z equal to, when z equal to 0, it comes, that is minus 2. Z equal to 0, yes, minus 2. So this will be minus 2. So minus plus, so 3 pi I. So 4 pi I minus 2 pi I, that comes 2 pi I. This is the answer. So left side is actually f of z by z into z minus 1 dz. So this again can be written as, that is 4 minus 3z by z into z minus 1 into z minus 2. This is dz. So this is the answer of this. Okay, this is the first sum. I think it is clear to everyone. So if you any problem, any doubts, you can call me. My WhatsApp number, that is 94330 This is my WhatsApp number. Okay. Now we are coming to example number 5. Okay. So example number 5. I am solving now example number 5. So what is example number 5? That is, you have to find out integration cos pi z by z square minus 1, that is z plus 1 into z minus 1. Okay. This is dz. This will be dz. Okay. This will be dz. This we have to find. Okay. To see the sum, you will see, you have to find what you have to find. That is solution 5. Okay. What you have to do? You have to find the singular point. What is singular point? At which point the function, this function is not defined. So that is to get singular point, to get singular point, we put denominator equal to 0. That is z plus 1 into z minus 1 is equal to 0, z equal to 1 comma minus 1. When z0 equal to 1, this can be written as, I am denoting the singular point, that is 1 comma minus 1 is the singular point. So 1 can be written as 1 plus 0 into I, that is 1 comma 0. z0 is equal to minus 1. This can be written as minus 1 plus 0 into I, that is minus 1 comma 0. So these are the 2 points, that is these are the singular points. At this point, this function, this whole function is not defined. So this is the singular point. So this is the singular point. Okay. After getting singular point, you have to find the closed curve. This will be given. Always the closed curve will be given. Here mod z equal to 3 by 2. This was the closed curve is a circle. I already explained in my first lecture what is closed curve, and examples of closed curve means starting and ending point of any curve is same point, starting and ending point. So here closed curve, you see, first I am drawing that is closed curve, that is z equal to what? 2 plus minus, that is 2 plus, you see, to get the closed curve, we see 2 plus minus I. This can be written as 2 comma 1 and 2 comma minus 1. Minus 2 plus minus I. This means minus 2 comma 1 and minus 2 comma minus 1. These are the 4 points I am getting here. So this is x axis, this is y axis, that is, you can say this is real axis, and y axis is known as complex axis, that is imaginary axis. Okay, so this is suppose, you see, this is 2 comma 1, this is minus 2 comma 1, and this point is minus 2 comma minus 1, and this point is 2 comma minus 1. So this is a rectangle. Okay, we are getting a, that is rectangle. Okay, so this is again closed curve. So now we have to check. Now after getting, this is the center of the axis. Now after getting the closed curve and singular point, what will you do? You have to check these 2 points lies inside the closed curve. If these 2 points lies inside the closed curve, then you have to apply Cauchy's integral formula. Okay, this is the thing. This is the thing. So we have to check. Now I am checking whether it is it lies along the closed curve or not. Along the closed curve or not. Okay. So you see this point from this to this is 2. So this point is 2 comma 0. Okay. And this to this again 2. 2 here is 1. This is 1. Okay. So this is 2 and this is 1. Okay. So this point is 2 0. So I am getting here 1 0. 1 0 will be here. That is 1 comma 0 and minus 1 comma 0. Minus 1 comma 0 will be here. This is minus 1 comma 0 because this point is minus 2 0. Minus 2 0. Okay. So this point, this is the point of this point. That is both the points, that is 1 0 here and minus 1 0 will be here. So these both the points that is 1 0 and minus 1 0, both the points lies inside C, inside the closed curve C. This is closed curve C. This is the closed curve C. Okay, inside closed curve C. So both the points inside closed curve C. So we can apply Cauchy's integral formula. Cauchy's integral formula. Just we had seen just a couple of minutes ago. We had seen what is the Cauchy's integral formula. Directly I am writing the Cauchy's integral formula, that is here what is fz, you see. So we are getting two singular points, both the points lie inside the circle, inside the rectangle, both the points inside closed curve, that is inside the circle, inside the rectangle. So we can take, that is the numerator part is known as fz. What is fz here? Fz is equal to cos phi z. Cos phi z is known as fz. Now apply Cauchy's integral formula. Cauchy's integral formula. What is Cauchy's integral formula? What is Cauchy's integral formula? Just so integration c fz by z minus z0, z minus z0 is equal to dz is equal to 2 pi I f of z0. So this is the Cauchy's integral formula. So I am applying over here, that is integration c. This is fz. What is fz? Cos z. So fz by z minus 1 z plus 1 into z minus 1. Z minus 1. This is dz. Now we have to break this into partial fraction. Partial fraction. So it will be, after getting partial fraction, 1 by 2, 1 by 2, that is z minus 1 minus 1 by 2 z plus 1. This is the partial fraction. This is the partial fraction. This integration c, then this is fz. dz. fz dz. Okay. Okay. So this can be again written as how to get this here half and half. So you know how to break this into partial fraction. I'm not doing here. Just I'm showing here how it is coming. That is just I'm telling, when you have to write z minus 1. Follow me. Just I'm saying, when you have to first you have to write z minus 1 plus z minus plus 1 here. Then what will be the numerator? In the numerator it will be, when z minus 1, that is equal to 0, that is z equal to 1, you have to put over here 1 by z plus 1. So 1 by 2 is coming here. Okay. Here z plus 1 0. Z plus 1 0. When that is z equal to minus 1, you have to put over 1 by z plus 1. That is minus 1 minus 1 minus 2. That is minus 1 by 2. Actually here is plus, here is minus 1 by 2. So plus minus I am writing minus. So now this again can be written as, this is half integration 1 by z minus 1 fz minus half integration c 1 by z plus 1 fz. Okay, dz. Oh, sorry. You have to write again dz also. Dz minus here dz. Okay. So now I am removing all this part. Okay. Okay. So this equal to that is 1 by 2. So what I am doing here, applying that is Cauchy's integral formula. Here applying Cauchy's integral formula. Applying Cauchy's. So 1 by 2. So this will be 2 pi I into f of z0 equal to, here z minus 1, z0 equal to 1, minus, this is minus half into 2 pi I into f of z0 equal to, this is what, z plus, this is actually z plus 1, so z0 equal to minus 1. So what is fz here? Fz equal to cos phi z. So what is f1? F1 equal to Z0 equal to 1. So F1 equal to cos pi, that comes minus 1. That comes minus 1. Cos pi is minus 1. Okay. And f of minus 1, when it is minus 1, then what is cos pi? That is cos pi, cos of minus pi, that is cos of minus pi, that is again minus 1. So what I am doing here, so pi 2 getting cancelled, that is pi I, that is into minus 1, minus this getting cancelled, pi I into minus 1. So uh, that is minus pi I minus minus plus pi I. So that comes, this and this getting cancelled. So 0 is the answer here. So 0 is the answer here. Okay. So that means fz by, therefore we can write, that is fz by this is equal to 0. That is, what is fz? Fz equal to cos pi z by z square minus 1 dz. This value is equal to 0 by Cauchy's integral formula applying. So this is the answer of second sum. So with this sum, I have finished, that is Cauchy's integral formula. So 3 lecture. If you follow my all these three lecture, I think you can do any sum, all type of sum I have solved over here. So I will request to everyone, you have to see my first, second and third lecture to know very nicely of Cauchy's integral formula. Next, in the next lecture, that is lecture number 4, I will come with Cauchy's integral formula for derivative of analytic function. Cauchy's integral formula for derivative of analytic function. This is actually application of Cauchy's integral formula, you can say. In the next lecture, that is, I will come with my new lecture, new video, that is Cauchy's integral formula for derivative. Okay, Cauchy's integral formula for derivative. Okay, first state and prove Cauchy's integral formula, then